Here we have another pair of physics concepts, which one of which is a vector and the other is a scalar. So in this situation, the distance is how far an object has travelled across the ground, and you just have to measure it along its route. So in the diagram below, we've got something starting at A, it follows a wavy route and ends up at B eventually, having done a distance of 49 meters. The displacement, on the other hand, is the straight line distance between your starting and finishing point, and must also include the direction. This is then called the displacement, and so in our situation here we have a displacement of 12 meters to the north, meaning that B is going to be 12 meters north of A. Both distance and displacement are measured in meters or kilometers or centimeters, so they have the same unit in that sense. The difference is that the displacement has to have the direction included. So what you've done here is you've started your clock as you go past one of these markers, and then when you reach the next marker at 1 kilometre on from that, so you glance down at your watch and you see that 40 seconds has elapsed. You jot that down. Go on to the next post, so 2 kilometres from your starting point, glance down and your timer now says 80. I've asked you what's the speed of the car and what's the velocity of the car. Now you should know that the speed, which you've learned in maths, is the distance divided by the time. So you're going to be doing 1000, which is the distance, divided by 40, which is the time, which will be 25 meters per second. Now, because it's the same interval of time for all of those, you could pick any of those pairs of distance and time. So I could pick the 4000, for example. I could do 4000 divided by 160, and I would still get 25 meters per second. So what is the velocity of the car? Well, the velocity of the car, as long as the car is going in a straight line, which we've said it is, then the velocity will be the displacement divided by the time. Now the displacement is 1000 and the time is 40, so that's the same numbers, which is going to give you 25 meters per second. But the difference is you're going to state it's 25 meters per second east. And that's the difference between the speed and the velocity on a straight piece of road. Now we know from our maths that the gradient of a line is the difference on the y-axis divided by the difference on the x-axis. So if we were to choose any point along this straight line, so let's choose the period between 40 and 80 seconds. So at 40 seconds, the vehicle is 1000 meters along the road. At 80 seconds, it's 2000 along the road. So we've got a period of time there of 40 seconds during which the car has travelled 1000 meters. So the y difference would be 1000, the x difference would be 40, so we'd need to do 1000 divided by 40, and that will give us 25. Now the gradient has got units, so it's the y divided by the x. Now the units on the y are meters, the units on the x is seconds. So when we work out the gradients, we are actually doing distance divided by time. Now we know, again, that the speed of an object is distance divided by time, which means in this situation that the gradient of this graph is exactly the same as the speed. Now, there's one further thing to get from this graph, and that is that we have a straight line graph. There's no variation in that straight line. Wherever we measured the gradient of that line, it will be the same. It will always be 25. Therefore, we say that we have here got uniform speed. Now, one final point to make here. In the syllabus, these are known as distance time graphs. We could call this a displacement time graph instead, if the object was going in a straight line. But the syllabus seems to only use the term distance time graph. So let's just explore that for a moment. If we had displacement in meters as the time goes by, then when we work out our gradient, we'd be working out displacement divided by time, and that would give us the velocity, because displacement's a vector and velocity equals the displacement, that's the distance travelled in a certain direction, divided by the time taken. So in that case, the gradient would be equivalent to the velocity, and in this situation here we would have a uniform velocity. We just have to make sure that we gave the direction of that displacement when we're expressing the displacement or the velocity. If you are in an exam and you're given a question about accelerating from a graph or a table of results, you need to first of all carefully consider whether it's asking for the average speed between two times or the instantaneous speed at a particular time. Now, how you work these two out is very, very different. So you've got to know what you're answering. Now, if you are taking a foundation paper, you will not be asked a type B question. You'd only have an A. So here we have a question where they're wanting the average speed between two times. This is between 2 seconds and 6 seconds. And this could either be asked you using a graph or from a table of results for distance and time. So you look at the graph for 2 seconds, you read up, and on the y-axis that comes to 6 meters. You then go along to the 6 and you go up from the 6 and you find the 6-second one is 42 meters. Now in the exam it is worth drawing a line from the 2 up to the x and then left across to the y-axis, and another line from the 6 up to the across and then across to the y-axis again. So your change of distance there, that's 42 take away 6, that will give you 36. The time was between 2 seconds and 6 seconds, so that's a total of 4 seconds. So your average speed is going to be distance divided by time, which is 36 divided by 4, which is 9 meters per second. So our question here is asking for the instantaneous speed at 4 seconds. So this time it's not between two times, it's actually at a particular time. And this is a skill you might well have to use in your maths GCSE as well. So worth really having a look at this. So from your graph, the first thing you do is you draw a tangent. Now a tangent is a straight line drawn that touches the curve at one point. And that one point in our case is the 4 seconds. And you'll see here that the tangent deviates from the curve upwards and downwards by about the same amount. That's how you know you've got the tangent correct. It should only touch at 4 seconds. Once you've got your tangent drawn, then you need to find the gradient of that tangent. And again, there's a bit of a skill, there's some shortcuts here. You're looking for places where the tangent crosses known points on the graph. And that's what I've tried to do with the green triangle there. So going across the bottom there, I've gone from the tangent across, and then from there upwards again to the tangent to make a triangle. Using the scales, I've then worked out that I've got along the x-axis, I've got 4 squares worth along there. Each square is half a second, so that's 2.5 seconds. And going up the other way, I can work out that I've got 24 meters on there. So my gradient is the y divided by the x, the distance divided by the time, which is 24 divided by 2.5, which gives me an instantaneous speed of 9.6 meters per second. To take your notes from this slide, you will need to construct a table with 7 rows and 2 columns. At the top of the left-hand row, you'll need to write the word activity. At the top of the right-hand row, you'll need to put speed. You've got 6 activities in the photographs there. You'll need to rank those in order of speed, starting with the slowest first. So you've got walking, driving on a motorway, running, a plane flying, cycling, and an intercity train. Once you've done that, you can then match each of those with the speeds given. Now you'll notice that 3 of the speeds that are given there are in red, and those are quoted on the AQA specification, and you are supposed to know those 3. Now those are the 3 for cycling, running and walking. You'll notice that 1.5 times 2 makes 3, 3 times 2 makes 6, so each one's double the other. Now they may well give you questions in your GCSE which assume you know those figures. So they might, for example, ask you how far would somebody cycle in 10 seconds? And that's it. Now in order to work that out, you'd need to know a speed to go with your time, and so you have to know the speed that links with cycling. Now in addition to that, the specification also says that you should be able to recall typical values of speed for different types of transportation systems. So for these you don't have to actually know the figure that's given there, but you have to get it reasonably right. And I've tried to round things off a bit there. So 3 forms of transport there, the ones in black. You need to know something like those figures there.